All right, let's go ahead and do some examples with this new equation, this average velocity equation we have just defined. So the first one we're going to look at is number 12. Again, this is going to be on page 3 of your packet. So number 12 reads, a runner covers one lap of a circular track 40 meters in diameter in 62.5 seconds. For that lap, what were her average speed and average velocity? So here in green, I have her traveling around the track in 62.5 seconds, and I want to find the average velocity and her average speed. Part B asks us if she covered the first half of the lap in 28.7 seconds, what were her average speed and average velocity for the first half lap? Okay, so we'll find that down here. All right, so in order for average velocity, I need to know where did she start, where did she end? That's what displacement cares about. So if you make one complete lap, what's your displacement? 0. Yeah, you start and end at the same spot. 0 minus 0 gives you 0. So you actually end up with a 0 average velocity for one trip around the track. So that brings up the point, is average velocity going to be useful for going in circles? No. Okay, so not a great use for going in circles. So guess what we're doing in this chapter? We're doing 1D motion, and 1D motion, it is more useful. Okay, speed. So now I got to know the distance, which is the path she took around the outside of the circle. And what is that called? Circumference, correct? And you might remember the equation for circumference is pi d, or some of you might remember it more as 2 pi r, and 2 times the radius is the diameter. So either one works here. So we'll notice that the diameter is 40. So 40 times pi gives me 125.7 meters. Okay, so her distance traveled was 125.7 meters in a time of 62.5 seconds. Here's a little pro tip for you. When you write 62.5 seconds, I like to write out the seconds. And the reason for this is sometimes I'll see students write, oh, the time was 1.2 seconds. And then they go to plug it in their calculator. What did they think they wrote here? 1.25. And so it'll mess up your calculations. So when you write that S for seconds, sometimes, especially if you're a sloppy handwriter, I would highly recommend writing it definitely smaller and even putting that EC on the end so you can tell, okay, that is not part of my number. That is the unit over there. Okay? All right, so plug that into our calculator, see what we get. Comes out, using proper sig figs, of course, 2.01 meters per second. Now our homework, we really just need 4. Every time, whenever we plug it into Quiz Evolve, we're going to need 4 sig figs on that. Okay, so 2.01 meters per second is what we get there with proper sig figs. All right, let's go to part B, which is our half lap. Okay, so now we're not starting and ending in the same position. So how far is it from my start to my end? And you'll notice it is exactly 40 meters in a straight line from start to end. Okay, so I have 40 meters divided by my 28.7 seconds. Gives me an average velocity of 1.39 meters per second. What am I missing? Yes, direction. I'm missing the direction, and so I would say this is to the left. Or maybe if I knew the directions of this track, I could maybe say like east or something like that. The distance, so this time it's going to be going half of this, or instead of 40 pi, it's now going to be going 20 pi. Divided by that 28.7, so we've got 20 pi divided by 28.7 gives me an average speed of 2.19 meters per second. So she was moving a little faster in the first half, and she slowed down. It brought her average down a little bit for the whole track. That's okay. Who doesn't do that, right? So there we go. That's an example. So in this one, it was a little easier because I just had to divide the two numbers and solve for the average velocity. So now I'm going to have you guys try a practice one, okay? So for this practice one, go ahead and read it and figure out what information you're given and what information you're trying to find. Hit pause quick. All right, so now you've tried it. So a couple things to kind of help you out if you got stuck here. That average velocity was 7 times the speed of sound, so 7 times 331. The distance for part A was 5,000 kilometers. you do have to make sure you change that into meters. So that's going to be 5 million meters. Okay, because you have to have common units. So if this is in meters per second, you need this in meters and this in seconds. And so you should have found a time of 2,158 seconds, or about 36 minutes to make that trip all the way across the country, which is just crazy that you can make it all the way across the country in 36 minutes. For part B, they want to know how far did it go in the only 11-second trip. So again, you have your speed of 7 times 331. You have your time of 11 seconds, and you solve for your distance. Now it does come out in meters, remember, and they want it in kilometers. So you got to chunk it off to make it kilometers, and you should end up with 25.5 kilometers for part B. Again, if you do get stuck on any of these practice ones, by all means, stop in to either office hours or just see me, okay?